Problem 15.2. So now consider a discrete time dynamical system, which is usually this way. So that here the xk is called the state variable, the uk is called the control variable. So the next state, suppose you're controlling something, and the new state of the thing you're controlling, which we call xk plus 1, depends on the previous state and whatever control you input. Okay, so this is a kind of linear dynamic system because the xk plus 1 depends on xk and the uk linearly. This a and b are some given values. Okay, so now given an initial condition x naught, so we know that the initial state is equal to 1. Then consider a problem of minimizing the x2 at time k equals to 2, subject to the constraint that the u1, u0, u1 are both have a magnitude less than or equal to 1. So we try to formulate this as a linear program and convert it to the standard form. Okay, so now it's clear that the x1 is related to the x naught and the u naught in this way due to this formula for the dynamical system, and similarly the x2 must be equal to that. Again, just set k equals to 2, k equals to 1. You get this. The question is how do we minimize this x2 under the certain constraint? Okay, so that we're trying to minimize x2, and the constraint is that x1 must be equal to that, and x2 must be equal to that. All right, and also the u naught u1 must be have magnitude less than or equal to 1. Okay, so now we try to convert this into the standard form. So now the variables we have are x1 is unknown, x2 is unknown, u0, u1, they're unknown. So we have four unknown variables. Okay, the x0 is equal to 1, so it's not a variable anymore. It's just a constant one. Okay, so now the objective function doesn't change. The linear equality constraints, we can move everything, all the variables to the left-hand side and all the constants to the right. So for example, this one, we have x1, then we can subtract the b u naught. So x1 minus b u naught. And we leave the a on the right side. So that's this. The second one can be obtained similarly, but remember that x2, x1, and u1 are all unknowns. That's why we keep them on the left. Okay, for these two constraints, we know that they can be written as, for example, this one can be written as u naught less than or equal to 1 and u naught greater than or equal to 1. Okay, and in that case, this simply becomes two inequality constraints like this. Okay, but every one of them is in the form of linear function. So, we know that these are just the linear inequality constraints. So this is a standard form. Remember that there are four variables. There are x1, x2, u0, and u1. There are four variables to be solved from.